Hi everyone, let's look at vector addition using graphical method. So there are two methods in which you can add vectors by drawing a scale diagram. Okay, they are the parallelogram method and the tip to tail method. Let's start with the parallel. So the idea of the parallelogram method is, of course, to form a parallelogram. We have a block here with two forces, 5 Newton and 3 Newton. So these two forces are at different angles from each other, and you can't simply just add 5 Newton to 3 Newton with 3 Newton to become 8 Newton. So for the parallelogram method, what we do is, first step, we draw a scale and we represent the two vectors with the correct scale and the correct angle based on the orientation that is shown here. Now, then what we need to do is these two vectors, we try to complete a parallelogram by drawing dotted lines, okay, as seen from A, C, and B. Okay, the resultant vector is then drawn from the starting point where the two vectors originated to the intersection of these two dotted lines. And then all you need to do is to measure this length, and this will give you the resultant vector. The direction can be measured based on the angles. I will use this question over here to illustrate how to do the parallelogram method. This question comes from the revision quiz 7. For the next method, let's look at the tip to tail method. So same thing, I have a block with 5 Newton and 3 Newton force pulling together. So what the tip to tail method is suggesting is that the resultant vector of a 5 Newton and 3 Newton force pulling together is the same as a 5 Newton force being pulled, followed by a 3 Newton force being pulled after you have exerted the 5 Newton force. So I think a better way to illustrate is by just virtually just dragging the forces. So let's say this is the vector diagram, right? So the resultant force of this vector diagram is the same as me moving the 3 Newton force to this side. That means the 5 Newton force pulls the block first, followed by the 3 Newton force. So the resultant of this two vectors is the same as this block. So you see that the tip touches the tail of these two vectors. So the resultant vector is then drawn from the starting point and then to the ending point where the second vector lands. Okay, so now if we do this the other way around, so the resultant force of this 5 Newton and 3 Newton block is the same as I apply a 3 Newton force first, followed by the 5 Newton force in the same direction. Right, the resultant force is still the same. I can just bring this over here to show you that it matches exactly. So basically, this uh, tip of this 3 Newton is joined to this tip of the 5 Newton. So either way, you will always get the same resultant force. And it will still be the same as how the parallelogram method works, as in the resultant force will still be the same, uh, whether you use the tip to tail or the parallelogram method. Okay, and here is the summary where you can see that how this is done. So 5 Newton force, then basically the 3 Newton force you draw in the same angle as it is based on the orientation of the block, and then by drawing the vector, the resultant vector from the starting point to the ending point of the 3 Newton vector, this is, and then you just measure this length, this will be the resultant vector that you have. So once again, I will illustrate this with this example, which you can see next.